All right, hello guys. We are going to finish up lesson 4.1. So let me present my screen and we'll get started. All right, so if you take out your notes from lesson 4.1, if you had printed them, we're just going to continue on. If not, and you're just doing them in your notebook, that's fine as well. We're starting with problem 11. It says to graph the polynomial function. Now, we are going to utilize our graphing calculator for today's lesson, although I definitely could graph this by hand if needed, right? If you are ever asked to graph a function, one way to graph is just to set up an XY table of values. So X, Y, where you pick your own X's. We usually start with -2, -1, 0, 1, 2, and plug each of those values in for the X to find the output, the Y. You can change the function notation to Y equals 16 minus X to the fourth. So you're plugging in for the first X value in -2. All right, that's going to be -2 raised to the fourth. -2 times -2 is 4, times another -2 is -8, times another -2 is a positive 16, and you'll get an output of 0. And then I'd have to do that again for each of the X values to get the corresponding Y. So that is one way that we could go through and gather points to graph this parabola. There's other options as well. We're going to use our graphing calculator. So let me pull that up. Oh, let me quit this. All right. So if you hit Y equals and then type in the function that was given, which was 16 minus X to the fourth, and then you're going to hit the word graph. Oh, so I had zoomed in before for another problem. Let me just first go to Zoom standard so that my screen looks like yours. Oh, it's still not what I wanted. Sorry, not Zoom stat, Zoom standard. There we go. Now my graph is still up too high. I can't see the top of it. So you could either change the window or zoom again. I'm going to change the window. My Y max right now is only up to 10 units. I'm going to change it. Let's try 20 and see if that's enough. Hit graph again. And now you can see your parabola. Okay, so that's the parabola that you want to copy down into your paper. But in order to have the exact locations, the exact points to plot, I'm going to hit second and then graph again, because in blue, see how it says table? So second, which is your blue key, and then graph will bring up the table values. And what you want to do is you want to find some points that would be easy for us to plot. So I'm going to focus in on just these points here, right? Because I don't want to graph -3, -65, or -4, -240. But these core points right here would make a nice graph for me. All right. So I'm going to copy those down onto my paper, and then I'm going to plot them to graph my function. So let me grab my pen again. So the calculator gave us the point, or again, I could figure this out on my own, but it was -2, 0, -1, 15, 0, 16, 1, 15, and 2, 0. All right, so let's make an XY axis for ourselves so that we can graph. So I'll just draw my Y axis. I'll draw my X axis. Okay. Now, if you take note that you have to go all the way up to 16 on the Y-axis. I don't have 16 units, so I have to change my scale along my Y-axis. I could change it on my X as well so that the diagram wouldn't be distorted, but it doesn't really matter. We'll just change our Y-axis. I'm going to count by fours. So I'm going to go 4, then the next line would be 8, and I have 12, 16, and 20. All right. So now I can plot my points, -2, 0, right here. Then -1, 15, it's about right here. Then 0, 16, it's about right there. 1, 15, and then 2, 0. And then you draw your function. Right. So that's how we are going to graph these using the graphing calculator. We'll do more graphing by hand and talk more about the different features of the function in our later sections. But let's practice again by working on problem number 11. So I'll start by using my graphing calculator. I'll plug that function in. So let me clear out this one. So this one is x squared plus 3x to the fifth minus x. All right, so I can, again, change my window, or I could hit Zoom Standard just to kind of get back to the main screen, right? If you want to zoom in, maybe it makes sense to kind of look right at that function by the origin. So you can kind of see more of what's happening. It goes through the x-axis, comes back down, goes back up, right? To get points to graph, I'm going to hit second and then graph because that'll take me to my table. I'm just going to look for some easy points. There's not many. There's only 3 points that I really want to use for graphing purposes. So I'm going to write those down. All right, so let me get my pen. So from the calculators table, I had -1, -1, and then I had 0, 0, and then 1, 3. Right, so let me get an X and Y axis nice and dark on here for graphing. All right, and I'll plot those points. So -1, -1, 0, 0, and 1, 3. Okay, so knowing, let me go back to my graphing calculator for a second. Knowing the shape of the graph again, you know that it's going to go up, it's going to come back down, and going to go back up. You might want to know what the coordinate of this point is and what the coordinate of this point is to help us graph. And we can talk about max and mins because that's actually where we're going to be going in the next lesson. If I want to know what the coordinate of this point right here is, and I'm using my graphing calculator, what I'm going to do, pull this over here. What I'm going to do is hit second, and then above the word trace, or above the button that says trace, it says calculate. And I want to calculate the maximum value. All right. And it's going to take you through those 3 series of questions where they want you to go to the left of the maximum. So here I'm like right on the maximum right now, but I'm going to go to the left. I'm going to push enter. Then I'm going to go to the right, because it says go right bound. I'm going to push enter. You can see that there are boundary lines created. And then it's going to say guess question mark, and you just have to push enter a 3rd time. And it lands right on the maximum and gives you the maximum value. So the maximum value, which I'll write down, let me move this over just a little bit. The maximum value is -0.6, I'll just round to, and 0.7. All right. Now, if I want to go to the minimum value, okay, I'm going to hit second, calculate. I want to go to the minimum this time. It's going to take you through those 3 series of questions where it says, first go to the minimum, go to where it is approximately, go to the left of it and push enter. Now, again, go back onto the minimum spot and go to the right and push enter. After you do your right and your left bound lines, you're going to push enter a 3rd time. It lands right on the minimum, and you're given the coordinates. We'll round that to 0.4 and -0.2. Okay. So now I have more points that I can plot, which will help me get a more accurate looking graph. So -0.6 and 0.7, we'll just say it's like right, that's not exactly where I want it, but right about there. And then 0.4 and -0.2, we'll say it's like right about here. Okay. And again, just knowing the shape of the graph, I know it goes up, it turns, it goes down, it turns again, and it shoots up. Okay. And we're going to talk more, I think it's in the next lesson, about the maximum, about the minimum, about turning points. This was like a quick little good introduction. All right. Let's move on to the next problem. Okay, next it says sketch a graph of the polynomial function f if f, the function, is increasing when x is less than -1 and is also increasing when x is between 0 and 1. And then we want to also draw the function so that it's decreasing when x is between -1 and 0, and then it's decreasing again when x is greater than 1. And f of x is less than 0 for all real numbers. So you translate that in your head to y is less than 0 for all real numbers. Okay. Describe the degree and the leading coefficient of the function of f. All right. So let's first, I'm going to use red for where my graph is increasing. And I'm going to use yellow to indicate where my graph is decreasing. Okay, and we also need to talk about this for a second because this is important. It says that all the y values are less than 0. Okay, and I'll translate that. I'll write that down. All y values. It's what f of x, right? We can always replace f of x with a y. So all the y values are less than 0. Are less than 0. Or in other words, when we say less than 0, doesn't mean they're all negative, right? So all y values are negative. So if this graph has y values that are all negative, what does that mean about where the graph is located? Let's talk quadrants for a minute. Okay, think about the quadrants of the graph. Let me see if I can go down. I wish the text would move when I move my page, but it doesn't, so I need to erase that. Okay, so what does it mean? Which quadrants would our graph be in if all the y values are less than 0, if all the y values are negative? So as a review, this is quadrant 1, this is quadrant 2, this is quadrant 3, and quadrant 4. So which quadrants have y values that are less than 0, that are negative? Quadrant 3 and quadrant 4. So that means my function, my graph, should only be located in quadrants 3 and 4. Okay, so right away, I don't know exactly what my graph is going to look like, but I know it's only going to be down here. I'm not going to have a graph that's up in those two quadrants. Okay, so that's what this last piece of information says. All right, and then I'm not going to scroll back up, so hopefully you have it written down or you printed this out. It says that the graph is increasing when x is between 0 and 1 and when x is less than -1. So, and I said we're going to use red to indicate that. So go on your x-axis. Where is x between 0 and 1? X is between 0 and 1 from here. Right, x is 0 there and here. So I know that in this region here, this is where my graph is going to be increasing, because for every point in this red region, the x values are between 0 and 1. Okay. It also says up in the directions that the graph is increasing when x is less than -1. So go on your x-axis. Where is x? Let's just start with where is x equal to -1? X is equal to -1 here. And then where is x less than -1? Well, it's less than -1 to the left of that point. So in this region, all of the points in this region have x values that are less than -1. right? So in this red region as well, my graph should be increasing, okay? Then I said I was going to be using yellow to indicate where my graph is decreasing. And according to the directions, which you can kind of see right up here, it says the graph is decreasing when x is between -1 and 0. So go to your x-axis, the graph, or excuse me, the x values are between -1 and 0 from here to here. So this region, this is where my graph is going to be decreasing. And then it also says the graph is decreasing when x is greater than 1. Well, x is equal to 1 here, and it's greater to 1 to the right. So all in this region, my graph should be decreasing. All right, so now that I know where my graph should be located, I know it needs to be below the x-axis because all the y values have to be less than 0. I know that my graph is going to be increasing in the red area, decreasing in the yellow, increasing in the red, decreasing in the yellow. Okay, so now's the fun part. Now you get to just sketch your graph. All right, so you just need your graph to be located below the x-axis. You need it to be going up. You need to be increasing in the red space. But then when you hit the yellow, you're going to turn and start decreasing. Now, how far do you go down? It doesn't really matter. I could just go down a little. I could go down a lot. I'm just decreasing. But as soon as I hit the red, I'm going to start increasing again. Again, how much you increase is up to you. You could go all the way up. You could go up just a little bit and start changing directions. And, oh, I changed directions too soon. When you hit that yellow, go back down. Okay, so again, this graph, which is a weird looking one, but this graph is increasing in this area, decreasing, increasing, decreasing. For every point on this function, the y values are less than 0. They all have negative y values, okay? And where I am increasing and decreasing, it met the conditions that were stated above. All right, you're gonna have practice with this for your homework tonight. You might wanna watch this section again. I know this takes a little bit of time to sink in, okay? Let's move on to the last problem for, oh, never mind, I'm not done this problem, I'm sorry. It says describe the degree and the lead coefficient of the function. And then we'll be done the problem. So the degree and the lead coefficient. All right, so think back to the first day, lesson 4.1, day 1. If both ends are facing the same direction, if both ends are facing up or facing down, what does that mean about the degree? It means the degree is even, right? Just like our parabolas are quadratics, degree 2, any even degree polynomial function is going to have ends facing the same direction. What about your lead coefficient? Is it positive or negative? It is negative. Again, just like a quadratic, if our lead coefficient is negative, we know our parabola faces down. It flips over the x-axis. It reflects over the x-axis. All right, so I know my degree is even, my lead coefficient is negative. All right, now I can move on to the last problem. All right. So here it says the number of students, S in thousands, who graduate in 4 years from a university can be modeled by the function S of t equals -1/4 t to the third plus t squared plus 23, where t is the number of years since 2010. Use a graphing calculator to graph the function for the interval t's between 0 and 5. Describe the behavior of the graph on this interval. All right, so we're going to use our graphing calculator. Let's pull that up first. Clear out what I have. So I'm going to hit y equals, I'm going to hit clear. I'm going to type in the function that was given. So negative, and then to get to your fractions, alpha y equals, so get your fraction options, and it's 1/4. They use t, we're just going to stick with our x's. So x to the third plus t squared, or x squared, sorry. And then, 23 plus 23. And then I'm going to hit graph. Okay, probably gonna have to change my window. Yes, I will. All right, first let me just zoom standard so mine looks probably what yours might look like. Okay. Now I am just interested really in, for this question at least, for the interval where x, or they say t, but x is between 0 and 5. So I'm really just interested in from here over 5 units, okay? But the graph is really high, so I'm going to have to change my window or zoom. Let's change the window, the y maximum. Let's change it to like 40. And if you ever change it and you still can't see the graph, or it's still too high, whatever, you can always change it again, okay? All right, so you can see the graph, right, from 0 to, let's actually change the window for the x-axis. And I change my x maximum to just 5. All right, so this is the portion of the graph that I want to see. And if you were graphing on your own, on your paper, you would copy this graph down. To get the points that you want, we are going to go to the table. And I'm interested in the x values from 0 to 5. So these are the points that I'm going to copy down onto my paper. All right, so I'll do that now. Where's my pen? There it is. Okay, so I had 0, 23, then 1, and it was 95 over 4, which is approximately 23.75. Then it was 225. Then it was 3, and then approximately 25.25. Then it was 4, 23, and then it was 5, 16.75. Okay. So it says describe the behavior of the graph on this interval, right? So what is happening through this interval? Well, you can see that the numbers are increasing, 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 but then they start to decrease. So that's what you can say. You can say from 2010, right? This represents 2010. From 2010 to 2012, 2010, 2011, 2012, the graph is increasing. And then in 2012, we start to decrease. All right. And then it says, what is the average rate of change? This next question, what is the average rate of change in the number of four-year graduates from 2010 to 2015? Well, hopefully when you hear average rate of change, you're thinking about slope. All right, so I want to know what is the change in Y over the change in X from 2010 to 2015. So here's the data for 2010. And then 2015 was the next one, right? 2015. So I want to know what is the change from, or the change in Y over the change in X. So you're going to set it up 23 minus 16.75, change in Y, over 5 minus 0. All right. And when you do your subtraction, you're going to have 6.25 over 5, okay, which is going to be, uh-oh, did I set something up wrong? Oh, I inverted my, sorry. This should be flipped. Let me fix that. Wasn't paying attention, right? It's 23 over 16.5, so it should be 0 over 5. 0 minus 5, which is a negative 5. All right, there we go. So it's negative 1.25. Right? So what does that mean in terms of this problem? Well, since we're in thousands, right, we have to multiply the number by thousands. So I'm trying to still squeeze this on before I have to move my page. Negative 1.25 times 1,000 is going to give you negative 1250. That means that the number of four-year graduates decreased by 1,250. I'll write that down after I clear this. So 1250 less students. Okay, and the last question. So the last question says, do you think this model can be used for years before 2010 or after 2015? Explain your reasoning. Okay, so think about this for a minute. Do you think this model can be used for years before 2010 or after 2015? Explain your reasoning. As you're thinking about that, let me pull up the calculator again. Change some windows around. All right, so one thing that I thought of when I read the question and answered it, I said you might be able to use it before 2010, but not after 2015, because the decline will result in negative graduates. Okay, looking at the graph, if we continue to use this model for after 2015, you're going to have negative graduates, which isn't realistic. But before 2010, where you have positive graduates still, a lot of graduate students, this model could potentially work. All right. So as long as you have some kind of justification for your answer and it makes logical sense, I'm sure yours is fine as well. Okay. All right, so that is the end of lesson 4.1. Make sure you take your notes and submit them to me, and I'll see you back here for the next lesson. Bye.